I don't wanna be. I do. I'm feeling groovy.
We talk about object-oriented programming, and what it seems to boil down to is we use hierarchies, trees of bits of information, and propagate events around them. Would that be a fair characterization of what we do? MVC, we have a front controller, send messages to it, and disperse that to another part of the program, and then call back to it using that mechanism. Would that be right? Okay. In some senses, it's only half of the equation, because we are using all the time phrases which only have one verb in them. So we call functions individually, or tend to, and although we nest them one in the other, it tends to be a simple language, and the objects are complicated, right? Or am I moving too abstract too quickly here? Right. We have half of the terminology that we need, I think. We have events, we have objects, they have characteristics, properties, and functions. But the notion is perhaps we should focus sometimes on how we can discuss and how we can talk about rationally using functions together, rather than focusing entirely on the shape of the data. Perhaps the shape of the processes is something that needs a terminology of its own, right? Okay. We'll see. We'll see. We can bootstrap this in 5 minutes. It doesn't take very long. It's not very complicated. It can be done. I'm about to do it. The only thing you really need to know in order to start to understand functional programming is pure functions. This is the notion that you are controlling the system, controlling a set of objects from the outside. In a lot of the time when you're doing event programming, you are inside a function where you will then produce some event which will be caught somewhere else and used, right? It has certain drawbacks. I'll probably get to those later, but coming from the other point of view, you should be outside of, I think, in some senses, in some cases, you should be outside of the data that you are using, rather than inside of it, inside an object, throwing events out of it, perhaps looking at the system from the converse view. You are calling from the outside into the set of functions. If you have a pure function, the data that you have beforehand and the data that you have afterwards are separate to the degree where you can use either once that function is called. Is that making sense? Because there are different versions of the data. If you go to it like this, it's the simplest possible explanation that I can find. You have a function, simple function, apply, and it appears not to do very much. We have the input being some state. It could be any object you can imagine. It could be an int, it could be a primitive of some kind, and the output is of the same type. The problem we have, and we're going to start from the notion that an operation fails, because that is, certainly in server-side programming, that is one of the things that seems to be a good start. If we call an operation on an object and it fails, if we've made any changes to anything underneath in the object tree whilst doing the operation, the input is the same as the output, and we can't recover from the error, right? That seems to be reasonable. If there's something wrong with the output object and it's been changed, we don't have the opportunity to return the original object, right? Seems reasonable. However, in the case of pure functions, because the original object hasn't been edited in any way, we can return that, which immediately allows you to play with data, right? You're not constrained by getting things wrong, because if you do, you can simply return to the previous version of your data and move on, right? Now, if you take that a step further, you've got another problem. It's gone wrong. So what do? You've got the object. If I go back a bit, because I'm starting to lose people, I think. Imagine we're in a programming language that doesn't have state on the object, in the context that you're in, except that comes through the inputs. Okay, that's the predicate here. That's where we're going into. The only function that we've got is this grift function. That's the only thing. Okay, we can't reach into the state of the object because it's not necessarily known, right? It's when you're dealing with state, you have to validate it. You have to know what state your system is in sometimes in its entirety, before you can do operations. So to simplify that, if we're working simply from the inputs, we can reuse this function, right? Does that make sense? Okay, sorry. I'm going to have a drink of water. I'll be back with you in a minute. It's not sounding at all the way it sounds in my head. So we're trying to. We're aware that an operation can fail, and we're aware that if we have a pure function, it doesn't necessarily matter. And now we have up here the original object and a function which doesn't work. And the notion is how to make it work. Okay? Is that obvious from the code up there? Not at all.
Just a question. Grift?
It's just a nominal word. It doesn't mean it could be any operation. It could be any operation. It's just an example. It's just an example. Apply.
Why did you name it apply?
It's a naming convention, basically. Yeah. By the way, rather than sitting there and being confused, please ask me, because I'm sure I can explain it. Don't worry. Just if you want to ask, any of you, really, please do.
And T2, why T2?
Okay. I shall go through this. Thank you very much, seriously, because I'm working off my idea and the difficulty of. Anyway, never mind. T2, it's a tuple. You guys use tuples, you know about tuples. It's just, you can only have one function return, so you just bind them together. And it's as simple as that. what I'm doing here is returning the original object having the function having caused problems with the internal state of y, and the function that caused it, right? Now, this notion of having direct access to the input and the output of the function is very useful, because it means at any time you can go back to the beginning of the operation and make changes before you call it, right? Does that make sense? Right? Which is a fairly playful approach. I know it doesn't sound like it because I'm sitting here like, but the notion of having the ability to change a thing before it happens is what we're talking about, because we have built an operation, and if we run it and it doesn't work, it's fine. We can take the same operation and prepend to it so that we can reuse that operation in different contexts and in different ways. And from the point of view of calling a single function which has state mixed in, we can start to compose functions together, and we begin to have like I said, a terminology by which we can talk about that, right? So, in the last function, we tried an operation, it didn't work, it doesn't matter. We return the original object plus the function that we tried. So the next bit would be to find out what was wrong with the original function and change it before we run it and bind two functions together in sequence, right? To adjust for the original problem, okay? Or the original situation. So, we returned a tuple. The tuple has a function primarily and the original state coming in to the apply. They have two operations, a FST operation and an SND, depending on which side of the tuple you want to get. FST stands for first, it brings the first bit back. SND is second, it brings the second bit back. And now you apply that function from the previous slide, we know that it doesn't work. So, what do we do? Well, it turns out, perhaps, that there is some part of the state of the object that you are using that is incorrect for the function you're passing it into. Right? You know, does that not make sense? You pass a function, you pass an object into a function, and there is some part of the state of the object which the function isn't prepared for, right?
So, excuse me, just that what you did is the assumption is that the problem was from the variable and not the function.
Hmm?
The assumption.
Yeah.
It's a problem because of the state of the variable,
yeah.
not from the function. Is that correct?
Well, it depends. You have to make assumptions in the functions that you write. You have to make assumptions in the operations that you write. But if clarify, please.
What I was saying, you said.
Sorry to do this to you. It's very nice of you to ask.
Thank you very much. Okay, so you were saying that somewhere in a function a problem occurred, and but the problem came from the variable or from the function. Is it important or not?
One would assume it would be the input state that was at fault, right? Because the function does what it does.
So
right.
The assumption is the function is correct, and you can.
Yeah, I suppose so. Yeah. Well, I don't know. No, it would. Yeah, I would assume that this. I would assume it would be some assumption in the function would not be compatible with the object that goes into it, or some state of the object, some field would be something that the function is not expecting, something that hasn't been, the sort of value level of the program rather than the type level. For example, you would, if you were to switch on a series of strings, and you had a set of transformations based on the name that you were to find in that particular field, and it wasn't in the assumptions that you had when you wrote the function, right? Does that make sense? The way, or one way with which you could deal with it is, rather than write another function or edit the function, you could simply prepend a function that would introduce the new assumptions that you're making, right? So, for example, if you had two use cases and one did not contain that key that you've got and the other did, right? You would rather than write another version of it, you would just prepend something which did the new thing that you would want to do. So at this point, is that clear?
Yes.
Okay. At this point, what we're doing is graft. It's grift and graft. That's sort of an English joke, because grift is when you don't want to work and graft is when you have to. We've got the original function coming in, okay? The first line, variable y equals x fst, which is the first component, and you run that with the second component. The next bit is to make the changes to the state of the object, the value, that would make it useful for the second function to run. So it wouldn't work until that, assumed or relied upon the fact that that there was a field called running in the object, and that it was set to true before the function would work effectively, right? If you introduce that into the first, if you introduce that before you run the function that comes in through your function parameters, and then bind the two together so that it would run the second, the new function you've written, and then the original function, now you've composed something which works. And rather than run it, if you run it and test it, there would be no error. The thing would carry on in the way that you would like it to. Okay? And rather than running it, you can simply pass the operation that works and the object that would go into it out of the function, and then run it later when you absolutely need it, right?
Why don't we use y? We store variable y.
That's simply to notate the fact that the function operates on the values and works correctly, having made a little edit to it, right? I don't want to use too much terminology, but you can see that if you create, are you guys comfortable with writing functions in functions and then using them? Yeah, everybody does that, right? This is sort of trying to systematize it a little bit, so we have a way of discussing it, I suppose. What's the confusion? If there's a sense of confusion, where does it lie? Is this too abstract? Not yet. Oh, cool. But it's you that said it. I can't possibly.
So is first being run twice?
It doesn't. If we're using, yeah.
Do we execute first twice? Sorry.
It doesn't. Yeah, no, it's fine. Using pure functions, we're not changing any state anywhere except the inputs and the outputs.
Understood, but we do in this case.
Yeah, we do, but it doesn't matter because there's no. It's not operating on any underlying state, so that we can be sure what the state of the program is anywhere else, before and after, and it will be the same. Does that make sense?
Yes.
It's one of these things that's really simple, and then you have to go through it layer by layer and see what the outcomes are. And one of them is you can fairly well predict the state of your program if you're using pure functions, right?
You mean you preserve the state?
The state comes in through the top and goes out through the bottom. Yeah, yeah, as much as possible. Yeah. As much as possible. Of course, you do have to get into that, but it's useful to have a simplest possible model. And one of them is to know is not to have to carry the stack yourself, right? You don't want to be. You don't want to have to be doing all of the. You don't want to have to carry state yourself in order to know what state the program is in. That's what the computer's for, right? So now you can take that operation, which you've taken from a failing state to a successful state, and you can pass that around, and now you know that it works. And this hasn't affected anything else in the program. This is completely isolate from the rest of the program. And it turns out, by the way, you guys, do you understand this? Do you understand this to a degree?
What's second?
Second, if you're using tuples, right? It's just first and second. First and second. It's just, yeah. That would be lists, I guess. Yeah. But the principle's the same. If you've got more than one thing to come out of a function, you just sort of bind them together in some way. Right. Any questions at that point? Is it not understood, or because if you do understand this, right?
No, I think so. I'm curious. What's the convention? Is it always? Do you always going to use the two people, and the first one is always a function, the second one is always data? I can't tell which parts are the convention that will have benefit, and which parts are illustrative.
The convention that has benefit is that in this position, right? Is that there is nothing that's happening in this function here which is dependent upon anything but what's coming in through the inputs. And there's nothing that's happening in the function which affects any state in the program other than what's coming in through the inputs. And if you like, you can return the inputs and there's no problem, right? And so every variable assignment here is a separate object from the one that's used to create the variable, right? So at each point you can move back to the previous state, right?
Understood. But it's important that the tuple that comes in first is a function, and second looks like data, which the data may represent work, which could be more functions, I suppose. It could be tuples, but first looks like it is a function.
The first is the function.
So is first always a function in a two-tuple?
Pardon?
Is first always a function in a two-tuple by convention? Should I understand it to mean that?
By convention. What I've explained here is one of the really, really deep, complicated things about functional programming, and now you guys understand it, right? This isn't entirely clear. If this was one type and this was another type, this would be the input type. Okay.
Okay.
And it turns out that this is called, it's called an arrow apply. It's a function apply in this situation. But you have the tuple of the input, the tuple, you have a function of a function plus its input, and it's mapped to its output, right? So you have a function, and in the top comes a function and the object that would go in that function, and then it's run and you have your output, or it would be run. Right, so we're deferring things, but we know what it is we're deferring to and when, right? No, not right. I'm still seeing confusion.
What is an hour? What is hour?
For this bit, you can just say function. It's the same, basically. There are differences, but for the minute, an arrow is a function, and a function is an arrow. So it's a function with a function in it, and its input. Right? Right. Now, we've done wonders, because this is a good bit, because this over here, this huge set of interrelated types is the Haskell type tree, right? And you can ignore most of it, because all of this has been sidestepped by the fact we just defined this. Okay, this is monad, this is a great monad, whoa. But no, we just did it, we just done it all. You've done it, you know functional programming. Right? If you can have a pure function and you can send it in the top with its input, arrow apply. And it's very general and very useful, and there's language we can use to talk about it. Right? And I'll come to that. Cool. I suppose so. I suppose so. But there it is. I mean, it's a nasty looking thing, isn't it? Two of something. Two of something, right? That's simple enough. We go from the right. Well, we go from the right-hand side. That's the output. That's what would come out of the function that if you were to run it. Okay. The input is a function, right? Some input and some output. And you know exactly what those two are. You don't necessarily know what it's doing. And the input. Just, we haven't done it yet. We have a thing, we have a ball and cup, right? They come together. We have a thing and we have something to do with it, and then later on we'll do it. Right? Because people are trying to overcomplicate it here, I think. We're trying to understand it on the level that we'd understand what we're doing day to day. But to have something that you have, and something that you would do with it, if you were to put the two together, and to take them around, isn't really a difficult concept, right? But if you try and think, well, what am I doing with now my code, and then you try and do, don't worry about that, okay? And that's it. That's functional programming, and it wasn't 5 minutes, but it was as close as I could make it. So next up, it's the silence and the not. Okay, now we've got details. Predicates. Now, how long have I been talking? Anybody?
Almost 4 o'clock. Almost 4 o'clock.
When did I start? Because I could finish there. I could finish there, and it would be
28 minutes ago you started.
Okay. I've got a feeling that you guys don't want to hear anymore, and I can understand it.
Any questions? Any questions here? You have a practical example? Oh, that's a good question.
Okay.
You have some
practical examples.
Yeah, an example. Okay.
Practical examples. Okay. We're going to skip the monad bit. Practical examples include this. Anybody use node? Node. Callbacks. You guys recognise it, okay? I said ignore that it was an arrow, and it was in fact a function. There's only really one difference between an arrow and a function, and that's function and an arrow. It's just a little bit of magic. And it turns out we've already had this magic for ages, just haven't defined it in this way. We have some input, and then later on, the event system of node or whatever will call whatever function you put in with the output that you're waiting for, right? You know, or if you, for example, if you listen to one event, it'll be the same thing. You add your event listener, and then later on, some event system or something somewhere will call in to the function that you provide. Yeah, you just wait. There it is. It'll appear, and you can move on. This is the essence of arrows, because it allows you, rather than each function being asynchronous, being synchronous and having to write code which looks completely different for asynchronous code. And it does, if anybody's written any. Event handlers, for example, they look completely different, they seem to function completely different, but in fact they don't if you look at them in this way. That's not going to help, is it? Okay, here we go. Here's an input. Here's something that will catch the output when it comes in. Okay? And we have two of them. We have something that happens before and something that happens after. Right? Now this is very simple when you're doing synchronous stuff, because you just move on to the next line of code. But because a lot of the languages that are out there don't support don't support asynchronicity, we have to sort of get around it a bit by using functions, because there is no way of having the next line of code wait for some server call before we get the data, right? We can't do that in JavaScript. I think we can do it in C#. I think it's, in fact, there's been talk of an async command in Haxe at some time or another. But for the time being, and to look at it in this way, we can put in the input, run some function, and then wait for it to return. And what we do here is each one of these, okay, each one of these, the before arrow and after arrow, are defined in this manner. So there's an input, there's a handler for it, and an output, right? And it's abstracted so that you just see the input and the output as the type definition. Okay, there is that happening. For example, this would be an arrow from string to result. That's the bit that you would see on the type level. And what's happening underneath is that. What we do is we write another handler, like another callback, like result void. And in it, we place this continuation into it, so that we run okay, makes sense that you do the first thing first. This is the input, this is the handler. The handler we had to write, okay? And it will call the next bit when it arrives, and only when. So we've now got a synchronization primitive, we've got an asynchronicity primitive, right? We can do things and plan things bit by bit. A, then B. That's the implementation. That's how it looks on the code level, which might be too complicated, because on the logical level, it's extremely simple. Extremely simple. We run F, we run G, and we output GFX. This one, and then this one, and then this one. And all of that talk, all of the blah, 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 it's just this. But we have a name for it. We know how it works. This one finishes, and then this one finishes, and then we output. But this and this are not normal functions. This and this could be arbitrarily complex. Go to any number of servers, anything, file system, blah, 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 blah. But you know it's encapsulated there. And once you have it, there it is, and it works. And you can string them together, and it's called a then operation. Okay, so all of the explanation, if you like, you can forget it, and just remember this. Because this is how simple it is on the level of writing it. But now we have a language for it. Then we have a first, right? Okay, well.
So you're now...
This is your input, this is your output.
You're calling F twice, or not? Or is F...
No, this is the accumulated function if it's sort of opened out.
Oh, right.
So, you know, this won't happen until here, and then when that happens, that's sort of a cumulative view of what's happened in this chain, okay? Am I still confusing people? Yeah? Mm. I mean, God, like, functional programming. It's trying to make it as simple as possible. And perhaps if I'd started with this.
Yes.
The thing is, now you have the formal explanation, and if you like, the implementation. Now the primitives. That's all the three components there, and you could use this stuff, and you probably are doing it anyway. But now we can have words, right? The first. This is the synchronization thing at work. There's two parts of the object. The first one is run with some asynchronous operation, and the second one comes along for the ride, and that's it. On the second, same thing except reversed. Now these are the first two are the only two things you need to know. Everything else in arrows is defined on the first two. First of all, you need to decide what happens after the other, and then you need to decide, well, can something happen and something else wait, basically, right? And the second is reversed. Pair, two things happen at the same time. This is a little bit more complex. If you use this, this represents an arrow. You'll have a name for this, and you'll say this, whatever the name for this is, dot join, and then you will introduce this function, or arrow, or server call, or whatever. The interesting thing about it is that the output of the first one comes along for the ride. So you can the original thing was to say there's been some function that's failed, and we rewrite it so that it succeeds. Well, this one we get both versions of the output. The one before this is run, and the one before it's run, and the one after it's run. And then you can do comparisons here. You can say, well, did it work? What are the input-output states, and make comparisons on those two things. Right, so synchronization, asynchronicity, a moment-by-moment understanding of how the program is running. I don't think, what else do we want? Yeah. Right? And bind does the same thing as join, except it's pushed back to the beginning, right? So that you get the... No, wait a minute, no. This is when you... No, wait a minute. You run your f, so f dot whatever, and then this one will act in some way on the two inputs. First, the original one, before anything has happened. Second, the one that's been through some sort of process. And then you can take those two, compare them, merge them, do things with them. Right? And that is it. It's no more complicated than that. We have 4 primitives, we've got one idea, right? And a lot of stuff that you may or may not care about knowing. But this is very general, and it will work for you if you're doing anything which is asynchronous. Asynchronicity is the big thing here. If you're going to servers, you're going to file systems, and you're using things, it doesn't, after you get over that level, it doesn't matter. It doesn't matter. The way it's implemented in stacks is that you can put any function in of any kind, and it will lift it to this structure, and you won't even have to know about it, other than to know that you can use a then, a join, a bind, a first and a second, and various other things. And there are more advanced things you can do with it that do things like hiding errors when you're doing operations which have error states that you don't want to handle explicitly. It will do things like that, which is also a useful tool. All of this comes from the notion of being able to objectify the system, and rather than from being inside the system and pushing messages out up onto some object hierarchy, right? I don't think I've made myself very clear here.
If I was taking something like loading an image,
Right.
if I was
Taking something like loading an image, for instance, and then wanting to do something like rotate it or something, but not knowing the sizes, is that something you might use this for?
There's an adapter. There's so many event systems that I've sort of lost track, but there is an adapter whereby you can wait for an event. So, if I back up here, this is an event dispatcher, right? This is a thing you put in the event that we're waiting for, right? And then you want to do something with it, okay? And that's all you need. If you're waiting for one event, you input your key and then you put the events dispatcher in it, and this function will run as and when that event arrives. Okay? All of this is asynchronous. So that's how that works. There are, obviously, because there's things like progress and stuff like that, which starts to get a little bit complex. And that, I know the Prezi team are talking about streams, and you have to do that sometimes when you're waiting for multiple events to come along. But for the simple case, for waiting for a thing to happen, this stuff is very cool. Anybody else?
Yeah, it's good to ask question right now. Is it you have a lot of slides or?
That's it.
Good. Oh, okay.
I
we can ask you questions.
Well, but I just saw.
Yeah.
No, I can't.
Yeah. You know, I think we are all object-oriented people from the object-oriented world, so we have to ask you some questions because it's really interesting. But I guess some of you really need to go back to the basis, right? And me too.
I'm not sure to have understood but everything well, but does it imply that you have to keep the states of an object? I mean, in oriented programmation, there are some objects when we don't want to be changing, we have to clone it because the function will do stuff in it, and so does it imply that we have to
talking about the cases where you're not using hashes and objects, when you are, it is, I don't know, there's that part of the program which is the fixed state and you can modify it and change it. But if you want to spin off processes when you're doing things with that data, right, the sort of composability you can get and the sort of the way in which you work is slightly different from each case. I don't know if that's an answer. You're right. It does come down to a state. It does come down to an absolute sort of representation of your data, and because it's not a pure language, you have to make sort of adaptations for that. But for portions of the program, portions of programming, and when you want to be, for example, you can hide things like synchronization code, because that is already built into the way that it works. If you're synchronizing things from different directions, and you need to wait for things to happen, and then continue with the process with the things in bound together, you can do that very easily with this stuff. It's not. I mean, this is a language for the processing side of programming, rather than a language for the object side of programming. Is that an explanation which hits home or hits the mark? I don't know.
So, Laurence, how does it work out when I want the result of something?
You just run
it. Hang on, not done. Right. Cheers, mate. So, when I want the result to go to multiple places, so you showed join where you sort of fractured and bind where you did part of a computation and then you used that part and the part you started with to start to do more. What if I want the result of one computation to go into 5 separate other paths? Like, can the paths begin to fragment like that, and how can they execute simultaneously? Like looping, I guess, in essence, is my question. Like, if the looping is all generating possible errors in themselves, it feels like the stream fragments, and what does that mean? How do you write code where you have to do things like that with this metaphor?
Looping is, you can do it, but you have to wait for the loop to finish before you can continue in this idiom. There is another idiom called iterates, which passes that loop around. It's something I've tried to work with. But when you apply one of these, you get back a promise. If you guys work with promises, right? Futures. It's an object which calls functions for you when the value's ready. So if you were to splitting off and binding it, you can add handlers to the results of one of these, and as many handlers as you like. As to specifically what you're trying to get at, I can't. I'm not sure. Do you have a more? I mean, I know.
I can try an example. So okay. I have some data. It's a number. I have a function that multiplies it by 5. Yeah. And then I want to pass that to 5 other functions. One of them adds 1, one of them adds 2, one of them adds 3, and one of them fails.
Right.
Right? I guess I don't understand how you accumulate the outcomes.
Well, it depends.
When the branch, I mean, would I have to define some policy in advance?
Then.
Okay, but how could I insert in the middle of once I've branched to work on the 5 different things, how can I put things back in the middle of the pipeline?
Well, that's part of the notion, is that you're composing small enough parts that you would say compose. You would compose half.
So I have to know the end of each branch when I'm breaking it or something like that?
It is planning computations. And if you were to have some other computation which only did half the functions and then were to do something else, you would compose the first bits and then you would run a pair, right? With the original set and the next set, and you would get your 2 results from the 2 different sets. I mean, this, in some senses this is complicated. In other senses it's as simple as it's possible to get. I see what you're talking about, but you would design your functions to be small enough so that you could build you could build them sequentially and just arrange them differently. Because if you think about it, until you apply a function, you've always got the input, right? You've always got that. So at any point, if you want to do something else, you could just do one of these, right? Or one of these. Say this was a non-function. Say this was a pure operation. You didn't do anything. You just passed the output from there and passed it out that end, right? All you have to do is write the dot join, okay? And you've got your input to do something else with it. Here. Okay. If there are any more questions, please do. You start off with a function, and you type dot then, and then another function, basically. The first function will have to be an arrow type for the compiler to match it. But after that, it will lift functions automatically into the arrow system, the arrow sort of way of doing things. It's pretty simple. It's sort of weird when you're preparing to do things rather than thinking about the values themselves to begin with, but that gets easier. I know.
Okay, we are running out of time. So you're really patient with us. Thank you.
No, because you're patient with me.
No, I think you just blow up some minds because we have some things which are certain for us in our conception of programming, and this is really interesting. You're really courageous because it's just such so hard to understand.
Courageous probably isn't the word. Right?
Thank you very much, Laurence.
Thank you.
And it's a pity you're not there tomorrow to answer more questions and do workshop, but I think we should organize a workshop if some people are interested the next time you go to Paris. Yeah. I don't hear
anybody. Yeah? That's okay.
Yeah, okay. Everybody seemed interested, so that's a really good point. But some did not understood what really how you to use it in the real life.
By the way.
Okay, so if you have one last word and then
one last word. There is, if we go back a bit. No, let's go forward. Seems to make more sense. There is, if you're comfortable with certain elements of functional programming, there is a fairly big library online. In fact, there's two, and we're trying to fix it so they work together. Stacks. I know there's an original one. That's my one, and then there's Simon Richardson, who's also doing the same thing, but he's got an actors library which is pretty nice, and we've got a bunch of monads. They all work in the same way. A lot of array comprehensions, predicates, maths, all kinds of bits and pieces of tools, and they're all in there, and they all do what they say on the function name. So if you want to take a look at that, it's there. It's a good. I mean, if you're interested in learning something about functional programming, it's a good way to start. Just to get in and see what a mess you can make of it, and have a go at it. And
is that your GitHub name, Obinu?
This one, yeah.
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 How do you pronounce that?
Obi-Wan.
Oh yeah, okay. Oh, that's great. Thank you very much. Okay. And yeah, everybody, you can ask him questions off the record. So, okay, thank you.
0-0.
Yeah, 0. Yeah. Thank you, Laurence. Thank you. You're so